Earlier this year, Apple revealed M1 Ultra, a monster of a chip containing two M1 Max chips stitched together in a way that allows the computer to treat it as one chip. This combination allowed the M1 Ultra to pack in 20 CPU cores, 64 GPU cores, and up to a whopping 128 gigabytes of unified memory. But how did Apple do it? I mean, you can't just duct tape two chips together and expect to get twice the performance Apple is claiming. Other companies have been trying this since the dawn of tech and failing every step of the way. Well, we all know the name Apple gave the groundbreaking technology, UltraFusion, but no one truly knew what Apple cooked up with TSMC to make it work. Pretty much since its release, people assumed Apple took advantage of TSMC's chip-on-wafer-on-substrate with silicon interposer, or CoWoS-Si for short, since it is a well-established solution dating back to 2012. Not only that, but Apple has used it in the past with their iPhones and iPads, so it would only make sense that CoWoS-Si would be used in this application, right? At the end of the day, this was only a theory, but the rumor was so well believed, TSMC actually had to step in and clarify what process was used to accomplish this feat. And it turns out that Apple is using TSMC's integrated fan-out design, or InFO for short, which on the surface is not too impressive since that base level technology has been out since 2016 and seen application in some of the latest Apple mobile devices. What is special is the specific type of InFO design used, integrated fan-out with local silicon interconnects, which has only been out since the beginning of 2021. What makes InFO LSI so special is the interconnect. Without it, the two M1 Max chips would have to share information over a relatively long distance, increasing latency and power consumption. This is due to having to pass the information through the substrate and then back to the other chip. For an easy way to visualize this, let's take the two chips and turn them into next door neighbors, and the neighbors across the street as the substrate, with the road acting as the connection points. Neighbor 1 wants to borrow power from neighbor 2. With the standard InFO design, they would have to run a line across the street, through the other neighbor's house, back across the street, and finally connect it to the neighbor 2's house. Seems inefficient, right? TSMC thought so too. So their solution, a local silicon interconnect. Using our previous visual, it'd be as simple as tossing the power cord over the wall from neighbor 1 to neighbor 2, decreasing latency and increasing efficiency. And that right there is the magic Apple used to pull off their groundbreaking feat. The silicon interconnect allows for the latency to be so low that the operating system can treat the two M1 Max chips as one. Not only that, but the interconnect's footprint is relatively tiny, only being a small bridge that barely touches the edges of each SoC. Even with being that small, UltraFusion still supports 10,000 signals from chip to chip. No other method comes close to the size to performance ratio achieved with InFO LSI. Not even the previously mentioned CoWoS-Si method can achieve that. And it's cheaper to produce too. But even with this bleeding edge tech, it would be reasonable to still expect some performance loss. Except M1 Ultra does pull off the impossible. Plenty of third-party sources have tested the M1 extensively, and it actually lives up to twice the performance it claims. And I have to give credit where credit is due. Nice job, Apple, for not only your accomplishments with the M1 Ultra, but the M1 lineup as a whole. And if you want to see more about M1, check out Taylor's video here and his experience with M1 MacBook Air. I'll see you next time.